Good afternoon, sir.
And I would like to thank you for joining us today. My name is Dr. Arshana Yadav, Assistant Professor, and today I have privilege of being your session moderator for this session. And now I would like to introduce our session chair, Dr. Anup Pratap sir from MIT University. And I extend my warm welcome to all our participants, both in person and online. We are excited to have such a diverse and engaged audience. So now we can start now. And Ashish sir, please you can start now.
I can share my PPT.
Yes. Sir, can you see your PPT now?
Yeah.
Okay, sir.
Um, Start करूं?
Yes, sir.
Good afternoon to all. Welcome to all in International Conference on Advances in Science, Engineering and Technology, July 2024. The topic of my presentation is First Order Low Noise Voltage Mode OTA Operational Transconductance Amplifier using capacitor for low power high pass filter for biomedical applications. Next slide, please. In this presentation, we will discuss some topics like introduction, proposed model, circuit description, the results and discussion, performance parameters of our proposed model, response curves, layout design, and finally summary and comparison. Next. In many analog circuit applications, operational transconductance amplifiers are one of the fundamental building elements. Low power consumption is an essential element in many aspects of contemporary electronic design, particularly for portable devices which are used for medical applications. Low power, low voltage, low noise OTA capacitor-based filter is our proposed model in this presentation. In biomedical applications, high-pass filters are required in analog front-end design for ECG signal acquisition system to remove the baseline wandering from the ECG signal, which is very low frequency phenomena generated from body movements and creates problems in analyzing low frequency ECG tests. Next, please. These applications require low power consumption and low noise characteristics for operating at low frequencies. However, as the order of filter increases, complexity of the circuits and number of floating capacitor increases, which ultimately increase the power consumption as well as noise and required chip area for our end design. Therefore, voltage mode high Therefore, voltage mode high pass filter with low order is preferred for biomedical applications. Because for biomedical application, we need very low power consumption and it should be also very low frequency cutoff. Therefore, first order OTA capacitor based voltage mode high pass filter is reported in this paper, which reduces the power dissipation utilizing minimum number of transistors and generate low cutoff frequency using reduced GM topology. Next slide, please. This is our proposed model. This is basically a high pass circuit implemented using sub-threshold operation. Here we use sub-threshold operation in order to reduce the power dissipation, and we reduced GM topology in order to reduce the cutoff frequency, that is higher cutoff frequency. Minimum number of transistors and other passive elements are used in this design filter, which is ultimately reduce the power dissipation. This apparently leads to a very low power consumption of the device, which is suitable for biomedical applications. Next slide, please. This is the circuit description what we have just used proposed model, where two PMOS transistors we have taken, PMOS 1 and 2, as well as two NMOS transistors are taken, N1 and N2, having their width and length ratio 10 micrometer oblique 2.3 micrometer for PMOS 1 and 10 micrometer oblique 1.23 micrometer for PMOS 2. And for NMOS 1, we use 2 micrometer oblique 180 nanometer. That is default parameter we have selected. We observe that positive supply of the gate of the NMOS is around 1 millivolt at 1 kilohertz frequency. VDCs, that is DC voltage, we have taken 10 volt. Current, that is MOSFET current, 1 nanoampere, and biasing resistor, that is usually R1, R2, R3 in this circuit is 1 kilo ohm each. And finally, input capacitance is 0.01 microfarad. Next slide, please. This is the result of our proposed circuit. We got the cutoff frequency 6.7581 kilohertz, power consumption 68.3218 picowatt, input referred noise 806 milliwatt per hertz, and output referred noise is 4.07 microvolt per hertz. Quality factor is 0.6751, selectivity less narrow selective, and total harmonic distortion is 0.344%. Finally, the chip area is used 378.871 micrometer square. Next, please. From the above proposed circuit, which acts as a high pass filter, here the proposed high pass circuit produces low order cutoff frequency, hence it may be used in analog front-end design for ECG data acquisition. This filter, shown in figure, used to remove base line wandering from ECG signal, which is low frequency phenomena generated from body movement or the respiration, and creates problem in analyzing low frequency signal. A filter here is considered more narrowly selective if its quality factor is high, and less narrowly selective if its quality factor is low. Because of its low quality factor, that is 0.06751, the design filter is referred to as less narrowly selective. Here we can see this input ECG signal, which is committed with the noise, and here when we use this high pass filter followed by notch filter, that is band reject filter, and low pass filter, we get clean ECG signal, which is possible by using low GM topology and reduced power dissipation because of subthreshold conduction. Next slide, please. These were the results from various filters, that is low cutoff filter, low pass filter, high pass filter, and this is the power dissipation, which is approximately 68.32 picowatt. Next slide, please. This is our layout, what we have used for this proposed circuit. Here we use area about 378.871 micrometer square with width 19.585 micrometer and 19.385 micrometer. In addition, the simulation after layout shows 2% difference in 3 dB frequency and 5% difference in consumption of power. Next. Here the table is given for comparison of various circuit like the same high pass filter. We can see one paper reported in 2013 using OTA technology, and it is first order filter. Here we see that cutoff frequency is 1.59 kilohertz and power consumption was very high, that is 223.2 milliwatt. And here in this our work OTA using capacitor mode, and this is first order filter using 180 nanometer technology. Cutoff frequency is 6.75 kilohertz with very least power dissipation of 68.3218 picowatt. This is the comparison chart basically. Next, please. In this work, first order voltage mode OTA capacitor high pass filter based on the sub-threshold operation and reduced GM topology, which is proposed for various biomedical applications. The design was simulated on and validated in GPDK 180 nanometer technology using Cadence Virtuoso and spectral simulation tools for this analysis. The simulation outcome indicates that performance in a linear from -40 degrees centigrade to 100 degrees centigrade. The circuit layout covers 378.871 micrometer square of space, and the power consumption varies by 5% between the pre and post layout simulation. The proposed filter exhibits 6.7581 kilohertz high frequency, consuming only 68.3218 picowatt power at 10 volt DC supply. Next, please. Thank you so much. Any questions?
Ashish, sir, can you hear me?
Yes, sir. Yes, sir.
Sir, I hope you have used some simulation tool.
Yes, sir.
So does it have any temperature parameter by which you can see your variance in temperature from -40 to 100 degree?
Pardon, sir?
Is there any parameter through which you are simulating your temperature also? You have shown your result now. It is linear from -40 to 100 degree.
Yes, yes, sir.
Is there any parameter available in your simulation?
Sir,
Yeah,
we
please.
have taken this Cadence Virtuoso using Cadence Virtuoso tool. We have set temperature range from -40 degree to 100 degree centigrade, where this circuit work well under these conditions.
Okay, okay. Thank you.
Thank you, sir.
Ms. Dipali, now you can join.
Yes, sir.
And please keep in mind, we have only 10 minutes for the presentation, okay?
Okay. Is it visible now? Good afternoon, one and all. Myself, Dipali Sakarabirada. I'm here to present a paper, two-stage peer selection in hybrid CD and P2P video on-demand system in International Conference on Advances in Science, Engineering and Technology, July 2024. So this is the outline of the presentation, that is introduction, related work, proposed system, result and discussion, conclusion and references. So there is nowadays there is exponential growth in online video streaming. So the reason for this, it may be the ease of accessibility and availability of multiple platforms. So there are different types of applications for video streaming, like gaming, live video streaming, video on demand streaming, video conferencing. So one of the application of video streaming is video on demand system. So in this, the users have a capability of on demand access. Then they have a location flexibility, from anywhere they can access the videos, and they can perform a VCR operation. So some of the examples of video on demand systems are YouTube, Netflix, Hotstar. So here, so how these VOD systems are built? So there are basically centralized and decentralized. So whenever there is a scalability issue, then we cannot use the centralized architecture because of single point of failure. So that's why there are different types of distributed architectures that are used. So there is a content delivery network, peer-to-peer systems. So in content delivery, that is nothing but a hierarchy of servers. So that will be built at different geographic locations. The aim is to minimize the distance between user and the server, so that the request will be served faster. So, this provides a good quality of service to the users, but the limitations or challenge is the cost. So here another type of architecture is a P2P systems, in which the nodes will act as a both client and server. So in this way, we can, for VOD system, we can use the upload bandwidth of the end devices. So here, but the issue is the reliability in case of P2P system. So there is a hybrid architecture, that is nothing but a hybrid CDN P2P system, in which both the advantages of CDN and P2P system that can be used. So here we are using, so this system will improve the quality of service along with the effective use of the resources available with the end users. So when we consider the hybrid CDN P2P system, there is a so effectiveness of that particular system depends on how we are forming the overlay of P2P systems under the P2P region of the of this hybrid system. So here, as in live, most of the license systems, what happens that they are considering the random peers, so there are random nodes, and they are forming the overlay. But this will not work for VOD system, because here playback point will be different, or there may be the large gap between the playback point of the users. So that's why here there are different parameters that are considered in literature for forming the overlay. So one of the author proposed to optimize the physical distances among neighbor nodes. So they are considering the physical distance between the nodes while forming the overlay. Another is that lifespan. So of the as a partners, in order to maximize the likelihood of and this chosen companion will have needed chunks. So that's why here playback point difference is the parameter they have considered. Another, they have considered that a dynamic neighbor selection by tracker based on playback point and younger peer. So whatever may be the new peer joined, they assume that there may be a higher upload bandwidth. That's why they are considering this. And then another one of the technique they have used in this actual paper is for live streaming. They have considered the stability or reputation of the node. So based on the age and then network position or closeness to the server, based on that, they are forming the overlay. So another, there is a one paper related to how the overlay is formed. So at first level, they are considering the upload bandwidth, and at second level, they are considering the chunk population. So here from this literature, so we come to know that we have to consider different parameters while forming the overlay. So here we are considering the hybrid system, that is so for our hybrid system, there are 4 components, that is source media server, in which all the videos that are compressed and that will be stored, and there are different CDN servers that are placed at different geographic locations. So whenever there is any request comes, then there will be the CDN load manager. So depending on the proximity and the load, that request will be assigned to the that particular server. And so fourth component, that is a peer, that is the end user. So in that forms the mesh overlay. So here important factor, that is whenever we form the overlay, so there may be 3 types of request or come to the CDN server. So that will be a new peer request. It wants more peers to share the request, or they can send the chunk request. And another is that already they are in the overlay, and they and whatever may be the neighbors available with him, so they don't have that chunks they are required. And other is that less number of active neighbors along with that particular node. So you want more neighbors. So like this, there will be the different request comes to the CDN server. So here there will be the tracker. It will maintain all this information, and based on that information, that nodes will be assigned. So here under every CDN server, for every video, there will be the different clusters, or we can say sub overlay, that are formed based on the playback point. So whenever any request comes, so how that particular nodes are assigned to the cluster. So if it is the first request, then it will directly connected to the server. Server will serve the request, and it will form the one cluster. And for subsequent request, it will check if there is a if the playback point of that particular requesting nodes falls within any cluster, so it will map to that particular cluster. Or if there is a multiple clusters available with that can be mapped to that particular cluster, then it will check the aggregate available bandwidth with that cluster. And then if no suitable neighbors are available, then it will be form a new cluster. In this way, that particular clusters are formed. Now here, so once that particular peer joins, there is a response. That particular node will send the heartbeat messages to the CDN server periodically, and along with so that particular tracker will maintain all the information related to that peer, along with that the clusters, so that he can map that every incoming node to the respective cluster. So, and if there are some requests related to that chunks are not available and fewer active neighbors are available, in that case, it will check the more neighbors in the same cluster. If they are not available, then it will it will check the neighbors in adjacent cluster, or it will be assigned to the server. So in this way, that particular data transfer will take place. Now here, after once that particular node is assigned to the cluster, the next responsibility is how to select the neighbors. There may be multiple neighbors within that cluster. So how to select the proper neighbors so they can serve the request. So that's why here we are proposing a two-stage technique. So here at stage one, peer selection at tracker level. So at tracker level, that particular tracker will suggest some nodes to that particular peer. And again at peer level, it will from that list, it will filter out some nodes based on ranking. So here we are for at first level, we are considering playback point and the upload bandwidth of the peers. And by using this equation one, we are finding out all the peers in the cluster having the playback point greater with that playback point of the requesting peer. And after that, so difference should not be less than the window size, twice of the window size, because if it is a far, then it may happen that that particular node will be exit the system. So that's why here by using equation one, it will find out the all the peers having the nodes with the playback point greater. And after that, once that particular nodes are selected, after that tracker will rank the peers from this list in
Sorry,
descending order.
your 10 minutes are completed. Please wind up.
Deepali, please come to your conclusion part.
Yeah. So this is a two-stage technique that we have used, and these are the different parameters that we have used. So these are the results that we have used three parameters: startup delay, discontinuity, and distortion. These are the three parameters, and we have compared with three techniques that is based on the lifetime. Similar factors that we have used for proposing. So same factors they have used, but at what level they are using. So based on that, we have compared that the startup delay, that is also, if you see the our system reduced the startup delay by 68%, 45%, and 31% respectively, as compared to other techniques. And even for distortion also, they have reduced the distortion by 29%, 19%, and 55% as compared to the other techniques. And this is the discontinuity. So already also our proposed system to reduce the discontinuity from 43, 27, and 24% as compared to the random LIVF and liquid stream 2. So this is the conclusion. So it is important that whenever we form an overlay, so what are the different factors that we are considering while forming the overlay? That is the important factor. So here we are proposing a two-stage, that is a tracker phase. Okay, so so that peers are chosen by tracker to recommend partners to recently joined peers. Secondly, the peer stage, the recently joined peers choose their partners from the tracker suggested list. So peer is chosen for each of the video to according to factors like peers, buffering level, playback point, distance, and upload capacity. So
Okay,
and we have come.
so you were showing one formula, P score. So have you typed this formula or you have taken it from somewhere?
No, sir, we have formulated that.
You have formulated.
Yeah.
On which
So
basis you have formulated? Have you calculated done some mathematical calculation, or how you establish this relationship?
yeah, so because sir, here we are considering that upload bandwidth and distance. So this is a P-score. We can say that. So here upload bandwidth, that is a very important. So how many users that he can serve? That's why here UBR upon streaming rate. So this is the streaming rate required, and if this is some specific X bandwidth is available with that, then how many peers it can serve. So based
Right.
on that, we can find out the capability of that,
So
and whether.
uh, suppose whenever you are searching for some of your cluster, And if that cluster is not available on the current network, so which algorithm you are going to use for that purpose?
Pardon, sir. I'm not.
You are looking for some cluster, right?
Huh.
To get your data, and suppose if any cluster is not available,
No,
so
sir.
have you
Here, the tracker will form the clusters. No? So here, based on playback point, whenever any request comes, so tracker
do,
manages all
do,
the
do you need
cluster.
to do you need to use some algo for selection of clusters?
Yeah, that's why this is the that steps I have explained. Na? So here, for every cluster, that tracker maintains the information related to what is the maximum playback point, what is the minimum playback point, how many nodes, and what is the average bandwidth available with that. If there is a cluster and if there are nodes with not sufficient upload bandwidth, then that particular node will not be able to get the required chunks. That's why
Okay,
here that is criteria is there.
thank you, Deepali.
Okay, thank you, sir.
Mr. Varad, Mr. Varad, now you can start your presentation.
Okay, ma'am. So I can share. Please share. One minute, ma'am. Wait a second. Yes, sir. Hello, sir. Myself, Varad Dahane. And sir, can you see my PPT?
Yes, it is visible.
Hello, sir. Myself, Varad Dahane, and I am from Anantra Power of College of Engineering and Research, Pune. My sir topic is Bharat Char Alliance essential to India's electric vehicle transition. Sir, here is our domain scope. It reduces air pollution and
Varad, please put it in presentation mode. Yeah, okay. Please go ahead.
yes, sir. Sir, it reduces air pollution and it is helpful for our economical growth, and it is cheaper than uh, other vehicles which is running on petrol or diesel, and the future scope is far greater. Sir, there are 65,117 EV sold since September 2020, a month after Delhi's EV policy was launched. 42% of share of two-wheelers in EV brought since launch of the policy. 5,940 total e-buses planned for the city, with the share of e-buses being 70% of overall filled by 2025. There are 234 battery swapping stations uh, till since 2024. 896 new charging points being installed uh, till 2025. 103 new battery swapping stations being installed. 18,000 total public and semi-public EV charging points aim to be installed by 2024. One charging station for every 15 EV targeted by 2024 at a distance of every 3 kilometers. So here are the plan of action. Align incentives provided to charging solution for priority vehicle segments 2 and 3 wheelers. Identify priority vehicle segments to determine which type of charges to prioritize. Identify statutory, regulatory, and market implements to set up EV charging or swapping stations. Identify locations with high dwell time for vehicles. Adequate distribution in unsafe or underserved areas through mapping and field actions plan for the different departments. So what is EV? An EV, an electric vehicle, is a type of a vehicle that is provided by electrical rather than traditional internal combustion engines that runs on gasoline or diesel. EV uses electric motors and rechargeable batteries to propel the vehicle. There are two main types of electric vehicles: battery electric vehicles, which is rarely sold on electricity store in batteries, and plug-in hybrid electric vehicles, which have both an electric motor and internal combustion engine and can be charged via an electrical outlet or run on gasoline. EVs are
Bharat,
considered more
Bharat,
environmentally. Yes,
please,
sir.
please come to your proposal.
Okay, sir. Sir, here is the introduction. The Bharat Charge Alliance is a public-private partnership working to develop a common charging standard for India and promote the use of renewable energy of power charging stations. The alliance is essential to the success of India's electric vehicle transition. Due to advantage of low energy consumption and pollution, electric vehicles have the potential to contribute to the decarbonization of transportation and the emerging of low carbon cities in may be an underestimate that technological innovation in the EV field is a topic of much interest. Electric vehicles can have positive impact on the environment by reducing greenhouse gas emission. Researching this topic can be a way to contribute to sustainability efforts.
Please come to your proposal part. Whatever you are proposing, please come on that point.
Okay, sir. Wait a minute, sir.
Proposal.
Just come to your work and findings only.
Yeah,
As
yeah.
we have
This is
limited
fine.
Sir, here's our proposal system.
Yeah.
Comparative charging infrastructure, extensive network of charging station, convenient access of electric vehicles owners nationwide, standardization, uniform technical specification for charging infrastructure promotes interoperability and coordination, universal compatibility, charging station compatibility with a wide range of EV models, encourages market growth and diversity. So here are the advantages. Environmental benefits: EV produce zero tailpipe emission, reduce air pollution and greenhouse gas emission, which can help combat climate change. Home charging convenience. Electric vehicles owners can charge their vehicles at home, eliminating the need of trips to be gas stations. Reliability: electric motors are known for their reliability since they have few moving parts compared to internal combustion engines. This can be result in low maintenance requirements. Affordability: historical EVs tended to have a higher upfront purchase price compared to the traditional internal combustion engines vehicles. However, this graph has been narrows as technology advantages, economics of scale, and government
Bharat,
incentives have helped reduce the costs of EVs.
can you please tell us in very simple terms what you are proposing? Just a summary.
Ma'am,
Have you done a literature survey or you are proposing something?
yes, ma'am.
What's your problem statement?
Wait a minute. Can you give me 1 second, ma'am?
Okay.
Okay, Bharat, please conclude your work.
Yes, yes, sir.
Okay.
Here the conclusion. In this study, we explore the improvements rate and technology trajectories and key assessment for EVs domains and subordinates to have a better understanding of the technology innovation in electric vehicles. Sir, the conclusion is that we are moving towards the electric revolution. So we need the charging stations across all over India, and there are few charging stations across all over India. The main part is we have to build the more charging station for our EVs to reduce air pollution. The estimate of technology improvement rate is study indicates that the higher complexity of batteries and electric motors resulting in relatively slower improving technology innovation than charging. In conclusion, while the Bharat Charge Alliance offers the innovative solutions to the challenges faced by the Indian CV industries, its success hinges on overcoming these hurdles and gaining broad acceptance. Yes.
Okay, Varad, thank
And
you.
sir,
Your idea is very good. There is a need of uniformity in the charging points of all EVs all across the India. So you
yes,
need some more better literature survey. You can make it more better, right?
yes,
So
sir.
it is good to see that you have done this work. Thank you.
Okay, sir.
Okay, thank you. Next.
Thank you, sir. Sir, hello, sir. Should I leave, sir?
Yes, yes, Mr. Varad, you can leave now.
Thank you, sir.
A very good afternoon to the panelists. I am Dr. Neha Mumtaz, Associate Professor in Department of Civil Engineering, Integrated University, Lucknow. And the topic of my presentation is Enhancing Disaster Management, a scientific exploration of artificial intelligence impact on preparedness, response, and recovery. In the recent years, the confluence of artificial intelligence and disaster management has emerged as a transformative force in reshaping the societies for preparing for the disaster or in seek of the response from a disaster or in the recovery phase. So the outline of the presentation is the introduction, research gap, objective of the study, research protocol, which will be having a bibliometric analysis, case studies, challenges and consideration, then the discussion and conclusion. So the introduction deals with like the disaster management evolution is related with the integration of artificial intelligence in transforming the disaster management, in improving the preparedness, response and recovery. And the significance of AI is underlying the capabilities of predicting the threats, enabling rapid responses, streaming recovery efforts, and reshaping the disaster management. So as you can see that there is a stages of disaster management before a disaster, which includes the mitigation part, and then comes the preparedness part. And during the disaster, the society is compelled to deal with the response of the disaster. And after the disaster, it is the recovery phase. So basically the role of AI in disaster management encompasses the various aspects, as you can see, the early warning system, flood prediction and management, disaster response and optimization, health crisis management, public awareness and communication, disaster recovery planning, remote sensing, and damage assessment. So this is the overview of the scenario. And the research gap which we have identified is the COVID-19 pandemic has been a very, new normal has been observed by everyone, but the pandemic exposed the vulnerabilities in the disaster management system worldwide. And the society grapples with the aftermath of the crisis, and the recovery, response, and preparedness phase gained very much prominence in that phase. Then came the numerous studies related to the application of AI in this particular comprehensive examination is dealing with the role of AI in disaster management. And then the isolated aspect of AI, which is like, without integrating this component into a cohesive strategy, how we can deal with a disaster. Though the fragmented approach limits the ability to fully harness the AI potential, which we'll be dealing with in the further slides. Now, the objective of my study is conducting a bibliometric analysis spanning the 4 decades, like 1985 to 2024, and the map of evaluation of AI in disaster management will be, analyzed. Then, using the lin-log modularity to visualize the research cluster and interdisciplinary connection with the field, I used the software WASViewer, which helped me in conducting the bibliometric analysis and about that lin-log modularity function. Then, identifying the emergent trends, influential areas, and providing of the AI application in disaster management. Now, this was the research protocol. As the literature review was collected from the scientific database, basically I collected from Scopus, and the literature retrieval system was like digital database. Scopus was used, and the major, the keywords were artificial intelligence and disaster management. So I got to know that only 1,192 research publications were related to this particular topic, and out of those, considering the inclusion and exclusion criteria, only 107 documents were downloaded and indexed and used in this particular study. So the literature analysis then comprises about the year-wise publication, the document-wise, and the bibliometric analysis. Then evaluation and discussion, recommendation and conclusion. So this was the research protocol which I used. Now, the bibliometric analysis, which was used by me by using the WASViewer software 1.16 version, you can see that there is a figure at the left side, which is like, you can see the red cluster is denoting the higher weightage, parts which are related with the artificial intelligence. Then there are segregated parts which are also related. So these are the terms and the basic keywords which were found during the analysis part. And you can see the document year-wise is like dealing with from 1985 till 2024. There is an enormous change, like the peak can show you that this is an emerging topic of research. Then came the document-wise segregation. So articles, review, book chapters, conference review, book, editorial, even the retracted version also were considered. Then letters, notes, which were like in a very nominal numbers. Conference papers were also considered. Now, the case study which motivated us to conduct this study is like the COVID-19 pandemic. A Blue Dot, a Canadian AI company, was the first one to identify the emerging trends by analyzing the news reports, airline data, and disease network. This is the only website which which also studied about the MERS, SARS, and other viruses also. So COVID-19 pandemic was a key thing. Then the floods in Kerala in 2018, IBM Watson AI analyzed the weather data, water level, and historical data to provide the flood prediction. Then the California wildfires in 2020, University of California, San Diego also developed an AI model. And then the Nepal earthquake, the drone imagery helped us in, the disaster assessment phase. Then what are the challenges and considerations? So the data quality and availability, AI is effective undoubtedly, but how we can rely on that? The quality of the data, ensuring what is accurate, updated data version should be used. Then the capacity building, the successful integration of AI in disaster management requires a skilled workforce, developing, implementing and maintaining the AI system. Then ethics and biasness. So AI algorithms can perpetuate biasness in the data, infrastructure and accessibility, because we are living in developing countries. So infrastructure and accessibility, even the financial constraints could be one issue. Then this opportunities and future direction. This is a part of the discussion. Like Collaboration between the government agencies are required. When I studied all the literature, I got to know that the research institution, tech companies can accelerate the development. And then skill development is also required, because we know we have to have a management professional who can bridge the skill gap and facilitate the AI adoption. Then real-time monitoring is also there. So the real-time disaster situation, enabling the quicker and better response should be there. And decision making should be there. Then customized solution. India is a diverse geographical culture and landscape, and AI application are there to tailor the regional challenges, because we are a developing country, as I already told you. So the conclusion of this particular study is like the dynamic evolution of AI in disaster management, the role in preparedness, in response, in risk recovery phase, then shift from the fundamental AI concept to the real world application. Then emerging dominant themes is like natural disaster prediction, early warning system in case of flood and tsunamis and all. Then post-disaster management, when a disaster is occurring, how we are going to deal it. So the post-incidence part. Then the optimization of the resource allocation is also considered. Interdisciplinary collaboration, as I already discussed, that the computer scientists, geospatial experts, domain-specific researchers can be utilized in studying the effectiveness of AI in disaster management. And then importance of interdisciplinary effort, which is very much important in the present scenario. Technological advancement are also there. Key role of machine learning, remote sensing, data prediction, data analytics. Then challenges and ethical consideration, that the data which we are having, it should be, the privacy concern should be taken into consideration. Need of a robust AI system, because we are having to have a very great amount of data which we are going to deal with. And then importance of disseminating the AI solution to the underprivileged region, which is very important, the financial constraints. Then the research limitation is also there, that fragmented research focus on isolated aspects, and lack of comprehensive framework in predicting modeling or real-time monitoring can be an issue. Then limited interdisciplinary collaboration, which is also there, and because we are working in silos and we are not expanding and intermingling with the other disciplines also, we're sharing the ideas and also implementing ourselves. Then theoretical models not addressing the practical implication, because the real world or the lab scale studies which should be enabled and utilized on the land scale. So the overlook ethical, privacy, biasness, fairness of the issue in disaster management and AI decision making. So this is all from my side. Thank you.
The study indeed was very interesting, and it also opened a new, you can say, discussion on enhancing the disaster management. The only thing that I wanted to ask was, what are the ethical concerns that are related with this?
Basically, the ethical concern is related with the data procurement, like what data we are enhancing, what we are getting from a particular person. Like everyone is not open to, when you talk about any survey, nobody is there to give the or appear in the survey. So the ethical consideration that the identity will be secreted, or it will not be revealed to anyone. This is the ethical consideration, because no other part is involved in it. It's a public dealing.
Yeah, ma'am. So you have shown some phases of disaster management, your first or second slide.
Yes.
So according to you, involvement of AI is most crucial. In which phase it is most crucial?
Definitely.
Can you come on to your second,
yes.
Second or third slide? Yes, this one.
So there are 4 phases, like mitigation, preparedness, response, and recovery. So the prime concern should be that we shouldn't be, proposing something like we shouldn't be waiting for the disaster. The prediction part is very important. Before the mitigation, you should be prepared enough and to tackle the thing. And the prediction of a disaster is way too important in terms of disaster management. We don't want a disaster to occur.
The same thing was implemented in our recent tsunami case, right?
Yes.
And second thing, whenever you are taking this term disaster management, you have to identify some field in which you are working, like you are a civil engineer.
I am environmental engineer, basically.
Yeah, so
yes.
You have to identify in which domain you are going to implement these all things.
Yes, sure.
And even AI is very vast field.
What type of AI?
Right. So
yes.
Your domain and the domain of AI which you are going to implement, these should be mapped.
Definitely.
Then definitely you are going to get great success.
Yes. Thank you. Thank you so much.
Mr. Midul Ranjan Chakravarti, now you can start your presentation.
Okay, thank you, ma'am. Thank you, ma'am. Am I audible?
Yes.
Is the screen visible? Hello? Is the screen visible?
Not no.
Not visible?
Not visible.
Let's try again.
Try to share the entire screen. Yeah, it is visible now.
Right? Okay.
Yeah.
So pardon me for my breakage of voice because I'm down with fever for last 2 days and having serious cough. Thank you for giving the opportunity for presenting the paper. This is a review work basically, which is a review on the optimal placement of UPFC in a fuel cell and wind integrated deregulated power system. I am Mithulanjan Chakraborty, professor from Techno International Newtown, Kolkata, and other 3 co-workers you can see here. So the outline is like this: introduction, then overview of EPFC, evolution of EPFC, then we'll compare various types of fuel cell technologies, and we'll study the impact of that, and then compare various types of fact devices, then methodologies for optimal placement and conclusion. Excuse me. So we all know that we are basically shifting towards renewable energy, and while doing so, we are facing some problem as we move towards smart grid, because renewable of integral energy towards smart grid is basically a challenge when you are integrating it with the existing power system. And as you are moving towards this in terms of various renewable sources, wind and fuel cells are very prominent nowadays, and UPFC, being a part of fax devices, is offering a solution where you can mitigate those complexities. This is the overview of UPFC. On the right side of the screen, you can see the static model of UPFC. And UPFC comprises of 2 functionalities, STATCOM and SSSC, that is static synchronous series compensator. It basically comprises of 2 converters, series and shunt, where series converter injects voltage with magnitude and phase angle which can be controlled, and shunt converter absorbs or injects the reactive power, and it can control the bus voltage also. So, and there is a DC link between these 2 converters, and these converters altogether forms the UPFC. This is the evolution of UPFC. In the 1988, the concept of fax device was introduced, and after this, in the year 1991, STATCOM and SSSC was introduced, and gradually this is the timeline as you can see. And in mid-20s, the integration with renewable energy sources came, and in the advent of power technologies improvement 2010, and then 2020 is the digitalization and smart grid integration started, and it came rapidly. So here are the various fuel cell technologies. You can see these are the PEM, SOFC, AFC, PAFC, MCFC, and DMFC. And the interesting part is that the operating temperature out of all these categories, the PM, AFC, these 2 are in the range of 60 to 100 and 60 to 90, and this is also DMFC is also 20 to 60 degrees centigrade, whereas the efficiency is in the range of 60 to 70%. But application wise these are different, and each has its own advantage as well as their disadvantages. And the impact of fuel cells, as you can see that, as I said earlier, that from the 2010 it started gradually capturing the market, and now we are in the 2024, and after studying the scenario, we have seen that in 2010 it was very small market share, but it 2018 it reaches almost 1 gigawatt, and in 2019 it reached the 1.1 gigawatt, with South Korea and Japan playing the major roles, and in 2023 it has reached up to 2.1 gigawatts. So with the advancement of hydrogen technology, this is taking a huge jump in this sector. And there are various types of fax devices also: SVC, STATCOM, TCSC, TCPST, and UPFC, that is Unified Power Flow Controller, which is Mike's point of study. Although the efficiency are all in the range are of high range, but this UPFC gives a comprehensive control of the active and reactive power flow altogether, which gives the advantage of UPFC over the other types of fax devices. Although the efficiencies can vary because operating conditions can vary, and our circuit configurations can also vary. So depending on that, we have to choose what kind of fax devices we need. But UPFC has proved to be a better choice than the others. And then there are various types of methodologies for deciding how to place it optimally. There are various methods: analytical, heuristic, simulation based, and MCDM. And heuristic algorithms are the most you can say resourceful and much more effective, but it may not always give the global optimum condition. So that is one challenge there. And finally, the conclusion: UPFC involves high initial cost, but after that, once it is installed, then the running cost is comparatively low. Integration complexity, and then adaptive strategies for optimal placement. And it is importance in fuel cell, that is, it is crucial for stability, efficiency, and reliability enhancement. And there are various methodologies exist for UPFC placement. So you have to choose what type of method you want to check. And challenges include the cost, as I've said already, and coordination complexity, and research priorities are there. So many research works are going on in this area. So out of those, the few are the adaptive placement strategies, smart grid integration, socio-economic factor, that is economic advanced analysis, and advanced control techniques like machine learning or introduction to AI in the in this process. Thank you. Hello. Am I audible?
Okay, thank you, Mitulji.
Thank you. Should I leave?
Yeah, you can leave. Thank
Okay.
you.
Thank you so much.
So, very good afternoon to one and all present here. My name is Vijay Lakshmi Mishra. I'm a research scholar from KNIT Sultanpur. So, before I begin my presentation, I deeply want to give vote of thanks to Integral University to give me an opportunity to present my one of the research objectives in this conference. So the topic of my presentation is neighborhood puzzle technique for greater power extraction from solar arrays under partial shading conditions or the varying indications. So next, I am having the outline of the presentation, which comprises of several points, which will be further discussed in this presentation. Now comes the outline, that is the introduction part. It is basically about the solar photovoltaic systems. As we all know that solar array is capable of generating maximum power when it is having fully illuminated condition. But when partial shading conditions like predefined shadings that are present in the environment, like tall buildings, structures, power lines, that creates a kind of shade on the system, which leads to the deterioration of the maximum power generation from the system. So to just overcome that, I have designed reconfiguration model of the solar array and developed its hardware prototype so as to verify whether the work that I have done in my research work through the simulation model is that practically feasible or not. So this is the types of shadings that are predefined shadings that are already existing in the environment, like tall trees, poles, adjacent panels, power lines, and so on and so forth, as shown in the figure 2. Coming to the, this is the one of the result or the output curve that I have obtained in my work, which is, see the, basically I have taken a 160 watt panel to extract the maximum power. This red line is telling about the maximum power extraction from the solar photovoltaic system, right? But when shading arises, it gets reduced to that green dotted line, which is showing that the initially when there was no shading, it was capable of giving 160 watt, right? But when the shading arrived, its power get reduced to between somewhat varying to 100 to 120 watt. So this is the proposed work where I have taken a single diode model in my system for the solar cell. Then coming to the table 1 tells about the various rating of the solar system, photovoltaic system that has been incorporated in my work. Yes, now comes figure 5, which is the total cross-site model. Here 16 solar modules are taken to which are connected in a total cross-site fashion. What is that? It is that these solar panels are connected in series and parallel connection, and several cross lines that are running between, they are telling that these cross ties are introduced just as to increase the productivity from the solar panels, so as to when the shading is casted on the system. Now comes the odd even system. This is one of the existing models in the literature. But this figure 6b is the novel proposed neighborhood puzzle technique that I have proposed for my research work to overcome the shading. These are the several steps that I have followed to design the solar novel neighborhood technique, where the models are being swapped across the rows and columns so as to get the optimized interconnection scheme, which is capable of enhancing several solar parameters. These shading cases I have used in my study, which is as corner and mixed. Yes, now comes the very main portion. This is the complete setup of the experiment, which I have designed manually from my end for the research work, which includes several instruments like voltmeter, ammeter, variable resistor, pyranometer, temperature sensor. Then a partial shading I have introduced in the work by using those color sheets that are present at the corner, green, red, pink, and so on. These are the shadings that I have introduced manually on the solar panels. Then comes the results and discussion, the very important portion of this work, which shows that under the fully illuminated condition, let me explain with this curve. Yes, when there was no shading, then the panel was capable of giving 160 watt. But as we can see, it is a smooth curve for the 160 watt. But when various shadings comes on it, it gets reduced and several multiple peaks on the curves are observed. So this was for TCT, then for the existing system, and this is for the novel work that I have done. Compared to the existing work, the one I have proposed in my work is capable of enhancing the various performance matrices such as global power between 3.24% to 16.77 as shown in figure 10a. And then it is capable of reducing the power loss between around about 12.06% to 44.68%. These various plots are for the TCT or even connection and the novel that I have proposed in my work. Then 2 more parameters like fill factor and performance enhancement ratio has been introduced. so as to deeply study what all authenticity and the means the extent of improvement has been done by the novel puzzle technique introduced in this work. This is the conclusion of the future scope, which is briefly telling as to how the novel suggested scheme is capable of enhancing the global power, power loss, and then fill factor 2. And the future scope of this work lies, like I have done this work for the small size panel that can be extended to the large size. Then I have taken like temperature and irradiation as the factors, but then there are many dynamic conditions prevailing in the atmosphere. One can opt that also. Then for further, we can take some, its application can be done for the commercial purpose too. So this is the references. These are all my papers that I have published in my research work. So yes, this is all from my side. Thank you so much. Any queries, please?
Can you please show the slide that was having the hardware?
Sure, ma'am. Yes, this one.
What is the significance of these color sheets?
Okay, ma'am. Ma'am, actually, my work is on partial shading. These thin sheets are introducing a shading on the systems. Okay, when this was placed in the fully illuminated condition, if we check with that pyranometer, it was telling about how much sun is giving that irradiation level. Okay,
that I understand.
Yes.
But the color is specific.
Yes,
there.
specific. Specific colors are there which are telling the what amount of solar irradiation is incident on that particular panel. Okay, see
for that particular color.
Yeah, like see, ma'am, it's mentioned.
And why only these 4 colors?
Ma'am, that depends. No, I have taken like several these colors like 100, 200. I have taken all sorts of ranging between means 528 to 635. From all ranges I have done in my work. But for the particular that type of shading where I propose the reconfiguration novel puzzle technique, I found that these irradiations are much more suitable than the existing one. So why not to, when we are improving the performance parameter, why not to go for the irradiations that we are getting, and that too also in an optimized manner.
And what is the array size that you have taken for your study?
Ma'am, it is 4 by 4, that is 4 rows and 4 columns multiplied to 16, total 4 by 4 it's, and I have taken 16 solar modules.
Up to what extent you think it can be extended?
Ma'am, 2 megawatt you can extend, means I have done it to 23 cross 23 also I have done, and it is adaptable in that conditions too also. Means for small size, medium size, and to a large size also.
Okay, thank you.
Thank you so much, ma'am.
So Vijay Lakshmi, so for these all shaded portions,
Yes.
you have applied this technique NPT.
Yeah, neighborhood
right?
puzzle technique.
So is it a sort of circuit?
No, neighborhood puzzle technique is a kind of algorithm or a swapping technique we have used in this method, so as to bring the, let me clear with this. See, we have 1 1, right? 1 1 1 2. Okay, this is the initial connection. Now what we see in a novel is 1 1 is there, but 1 1 adjacent to it, initially it was 1 2, but now it is 3 2. The solar modules are swapped, their positions are interchanged along the row or a column, when finding that for that particular connection scheme, while swapping the modules from their initial positions, they are giving more optimal results. Okay, so this is the algorithm that we have used. Okay, internal electrical connections would remain the same. We can't change that. But yes, physical relocation we have done for the predefined shadings that are already present in the environment. Sir, hope I'm clear. Thank you so much, sir.
Naveen sir, please start your presentation. Naveen sir, please start your presentation. Naveen sir, am I audible?
Naveen ji, can you hear us?
मोबाइल से कनेक्ट कर लीजिए, पीपीटी आप शो कर पाएंगे? ठीक है प्लीज सर, वो कनेक्ट कर रहे हैं लैपटॉप ऐप से
Hello,
Yes, please start your presentation.
am I audible?
Yes.
Okay, fine.
Naveen sir, please start your presentation.
जी 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 मैं शेयर करने की कोशिश कर रहा हूँ मैं.
Okay, sir.
Hello, can you see this PPT? Can you see this slide? Hello. Hello. Is this PPT is visible to you?
Not yet. Navinji, it is not visible to us. I hope you are doing it from your mobile.
Yes, actually, I am online from my laptop, but my voice is not reaching to you. You people
Okay,
are audible to me, but I am not audible to you. So that's why
okay.
I have come online from mobile.
Please share your PPT. It was visible, I think, few seconds earlier.
You can share your PPT via laptop.
Okay. Can I go through this? Is it visible?
No.
Hello, now it is visible to you.
Okay, it is visible now, but it is flickering and moving a lot.
I'm focusing my mobile to laptop.
Okay, you please go ahead.
Okay. First of all, extremely sorry for all the inconveniences that due to some bad things in my laptop has been created. Good afternoon to one and all present there. Myself, Navin Kumar Bin, working as assistant professor in JSS Academy of Technical Education, Noida. So today I am presenting my research paper titled as Enhancing Photovoltaic System Stability Under Varying Weather Conditions and Unknown Load Scenarios. So as we know that in a photovoltaic system, the output is highly unpredictable due to the external factors, just like the varying weather conditions and unknown load scenarios. That means upon which type of load that system is going to work. So my outline is, first of all, introduction. My outline is introduction, then proposed model, discussion, and then conclusion. So introduction is, in this introduction, recent advancement in renewable energy, particularly in photovoltaic system, heavily rely on a robust and stable grid integration to smoothen the energy storage in grid. That means we have to rely on lot of parameters for a stable grid integration. Then the performance and the stability of producing clean and renewable energy are closely related to external disturbances that I have explained earlier. That means varying weather conditions and unknown load scenarios. That means on which type of load it is going to work. So because we know that solar energy rises and falls discontinuously due to varying weather conditions, including clear skies, partial shading by clouds, and growing heavy clouds. So now model, that upper model is the proposed model that I have created, that there is a PV with the help of which inverter is connected, and then the power is fed back to the grid. And then we will take some variables from the grid to the control strategy of inverter, with the help of which we can control the parameters of inverter. So we know that for maximizing the output, we use MPPT theorem. So there are some algorithms, just like P and O, fuzzy logic, NN, incremental conductance. So I have compared three of them, that means P&O, fuzzy logic, and NN. So there are some criteria like stability, efficiency, adaptability, implementation, and computational requirement. So upon these criteria, the performance of this photovoltaic system is prepared for all the three algorithms, that is P&O, fuzzy logic, and NN. So what we have found that this table you can see that comparison, that for getting a constant voltage of 145 volts out of all the three algorithms, we found that NN, artificial neural network controller, is giving the highest output power, that is 230 watts, and P watts, fuzzy logic is giving 225 watts, and NN is giving 230 watts. So from this table, we can conclude that out of all the controllers, that means old ones like P&O and incremental conductance, and the new ones like fuzzy logic and NN, NN is giving the highest output power. And this is the table. This is the table which is showing the comparison of all the three controller, like that is P&O, NN. So in the last, that is the conclusion, that the stability of the PV system under varying weather conditions and load scenarios is a critical factor in ensuring reliable and efficient power generation. Out of all the MPPT algorithms like P&O, fuzzy logic, and NN, the NN-based MPPT algorithms outperform others, providing the highest output power compared to fuzzy logic and perturb observe. And these algorithms dynamically adjust the operating point to maximize power output, accommodating changes in solar irradiance and temperature. Then I have used one more characteristic of inverter, that is called as LVRT, low voltage ride through capability. What happens actually during the disturbance, suppose that voltage sag, in a situation of voltage sag, the PV system will automatically disconnect from the grid. So this LVRT parameters holds that PV system into the grid so that it will not disconnect from the overall system. So I have used this LVRT system also, so that the overall efficiency and overall capability of the grid, that will enhance. So these are the conclusion points. Thank you.
So Navinji, this is analytical study, or you have simulated your results somewhere?
Sir, I have simulated also.
Okay, so which tool you have used for this?
MATLAB and Simulink.
Okay, thank you.
Thanks a lot. Thanks a lot, sir.
Okay, thank you. You can leave.
Okay, sir.